let's see. How are our overall grades in here? Um, there's just a small handful of people that are struggling to pass. A lot of people doing really well in here. Some of you guys are just killing it, man, just fabulous. And then there's a couple in here that are going to have to put in some pretty good work. And we don't have a whole lot of time left. If you're a senior, you really don't have much time left at all because next Friday's the last day of classes. Next Friday is the end of the classes. Then there's just the senior finals Monday and Tuesday for any finals you might need to take. And I haven't seen an official anything yet on that. You know, you can exempt everything in the spring, so you don't necessarily have to take any finals. So, all right, it is 12:50. We are going to have a ton of folks that I'm counting absent today, but that's on them, not on you guys. You guys did a great job getting here, and you'll get a little of a little head on understanding the assignment this week because I kind of like this one. Let me get on the right screen here before I put this up. I redid this assignment this year, and I like it a lot better than what I've done in the past. No, I did turn in the test. Yeah, you should be done with the Module 5 exam. Should be on 6.01. So everything above that should be turned in, all the programs. And I will remind everyone that I have videos in there. If you're missing any programs, there's help with the 5.04 program. There's help with the 5.02 program. It's a 9-minute video on how to write that program. The 4.06 program, the 4.04 program, the 4.02 program. So I have all these videos I have added in Google Classroom to make this much, much easier on you. I even put an extra little guide for the superhero program to make that easier on you. And I do want to show while we're talking about that, there are some really good ones. Let's see. I think I've got these saved here. Superhero. All right. I've taken the name off of it because I haven't asked the student if I could share their program. So I'm not letting you know who it is. But create your own superhero. Here is the class that you were given in the Add Strength and Save World. And then here is what the student wrote. And when we run this, look, Tanella tunnels through every bit of earth, clay, and rock in order to get from place to place. Now, look, when they wrote the program, they did hero.name, did hero strength points, hero.name. Every time they referred to the hero, they did hero.name, hero.name, hero.weakness, hero.name, and just built the story around that. Hero.strength points. Here's where they added strength points. Oh, and they added negative strength points. This is what I thought was pretty clever. Says, and one day as Tanella was digging a path for Mrs. Mole and Mr. Badger, she ran into a pipe and lost 52 of her energy. So this person actually used the add strength points to deduct points. Look, it says they had a strength of 110, which was what the hero strength points were at the time, but now only 58 because they subtracted 52. So they had it add negative points, which I thought that was very clever because I hadn't even thought of that. I hadn't even talked about that. And then it says, with all the strength she had, she shouted, tunnels unite, and her strength came back even stronger than before, and she added 110. And tunnels unite was the motto. And finally, at the end, she called the Save World thing. So this was a really good program. This was one of our ladies has written this program, but it was really good, and I wanted to show you that too. I have another one. I want to show this other one as well. Here it is. Okay, again, I took off the name. Here is all the stuff that was given. Nothing's changed there, but here's where they created their hero. And then the story. And look, they got a pretty long story. And they use add strength points, deducted strength points also, and added strength points again. Monkey Man was feeling a bit weak with only 100 in strength points. So notice he just put myhero.name, myhero.strength points, add strength points, myhero.name, myhero.name. Everywhere you see Monkey Man in here it was myhero.name. So if you wanted to change it and didn't want it to be Monkey Man anymore, and you wanted it to be Batman, if you just change where you create that and run the program, oh, look, everything changes to Batman now. This is a great program written properly everywhere. All you have to do is change stuff in here where you create the hero, and that will change everything in the story. So you can easily update things. Great, great program. So I wanted to bring that out there. But anyway, let's get to this. All right, you're good. We're just getting going. So let's go. 6.01 is our lesson. It's all about testing. Close module 5, open module 6. Testing. Testing 1, 2, 3. It's the moment you've been waiting for. Your server places the pizza of your dreams on your table. It's got extra cheese. It's piled high with all your favorite toppings. Seconds later, you grab that slice, you take a bite, and was that cheese molten hot magma? The top of your mouth is now just a big scab, right? Of course, this horrible situation, I'm talking about the burn, not the pizza, could have been avoided with a little testing, right? Check to see how hot the pizza is. I mean, it takes time and a little patience, but pizza is much more enjoyable when it's not the source of second-degree mouth burns. In programming, taking time to test is a crucial step in ensuring the quality and usability of a program. It's also the only way to avoid unplanned disasters. We'll talk about later. So after this lesson, you'll be able to explain the types, uses, and limits of testing to ensure program quality, determine when in program development types of testing are performed, explain how data and test plans are used in program testing, and describe the role of customer service or customer support and satisfaction when releasing your software. Hashtag oops. Have you ever burned $125 million? NASA has. In 1999, NASA engineers working as part of NASA's Mars exploration program had been communicating back and forth with the Mars Climate Orbiter for a period of 9 months. Here's a picture of the Climate Orbiter. There was just one problem. The orbiter was speaking to NASA using metric, and the engineers were replying back with our English units. So, of course, they didn't realize their mistake until the orbiter was orbiting too low and too quickly into the Mars atmosphere. They forgot to conduct a conversion test. They didn't test enough stuff when they wrote the program. They could have caught this error before it happened. So instead of orbiting Mars at the height they wanted to, it plunged too low and crashed and totally gone because they did not test the program and realize that it was using metric system instead of our standard English system. You may think errors this magnitude are rare, but that's not true. Software bugs cost the U.S. economy about $60 billion every year, according to a study by the National Institute of Standards and Technology. That's billions with a B, ouch. Testing, not optional. So considering the cost of errors and humans' tendency to make mistakes, testing is mandatory when developing software. In fact, there's even different levels of testing that take place throughout the stages of software development lifecycle. These testing levels provide opportunities to identify errors and bugs before they get to be expensive or annoying or possibly explosive. Let's take a look. So there's unit testing. So developers usually conduct this type of testing during code development. The goal of unit testing, verifying sections of a single program, is to ensure that sections of the code are functional, that they meet the stated requirements and they're working as expected. It's like running spell check on every paragraph of your research paper instead of waiting until the end. Okay, I'm done with that paragraph. Let me run spell check. Okay, that part's good. Let's go to the next paragraph. Integration testing. When different components of a program are connected, integration testing ensures that the behavior and functionality of the program are working as expected. Checking the connected parts of a program and the interactions. Sometimes integration testing happens all at once, like just do a big bang, right? Sometimes it follows a specific order, top down or bottom up. So it's like making sure that each paragraph in your paper supports your thesis and works together as a whole, right? It makes sense with the other paragraphs. It doesn't say something totally opposite of the other paragraphs. It all works together. System testing. So this type of testing ensures that the entire system is working as a whole. During system testing, it's verifying the behaviors of the entire system as stated in the original objectives. Developers test the program in an environment that's very similar to how the program will eventually be used. Like if you're writing a program on some Python website for this class, you need to test your program in Python idle to make sure it works in Python idle. Because if you're doing some other Python, but in Python idle, there's a good chance some things will not work properly. This type of testing is quite rigorous. It's often performed by a specialized testing team. Maybe somebody else takes your program and runs it and tests it. So it's like reading your term paper very carefully, identifying errors, and revising your drafts before turning it in. It's done, and you go back piece by piece, you check everything. Acceptance testing. So it's often called user acceptance testing. It's confirming that a product's readiness and customer acceptance. So this process is carried out by a quality assurance team. So it's a team whose their job is just to make sure that the program actually functions and does everything it's supposed to. During this type of testing, the QA's goal is to catch simple errors like spelling mistakes, image errors, you put the wrong picture up there, major errors, bugs that might result in system crashes. It's like turning your paper in and then receiving feedback from your teacher on how to make it better. Okay, I like this. Your paper's good, but I'd make this change, and check out you got this misspelling. And, just make sure. Automated testing. Sometimes your code will go on for miles. It could be a really, really long program, and there's potential bugs hidden that could take hours to find. That's where automated testing comes in. It's like letting the AI test your program. Doesn't require a human. Many developers run automated testing programs. You could write a program that tests another program. So it's running automated testing programs overnight so you can come back to work in the morning to get a list of all the bugs. So you could have a program, look at this. You may have this huge program that's tens of thousands of lines. You run this other program that tests that program with all kinds of different inputs and generates a list of the ones that had errors. Hey, when we entered a negative number, it had this error. When I entered a decimal number, it had this error. It's like running spell check on your word processor. Usability testing. This is when the developers get to see their work in action. During a usability testing phase, developers let users play with the software to see if you can break it. All right, here this is. Put some input in there and see if you can find anything that doesn't work. This helps identify bugs that would have gone unnoticed because developers don't always anticipate the things that users might do with their software. It's like getting other people to read your paper, report back on the things that worked and things that didn't. It's like, oh, I didn't even understand this page. Regression testing. These days, it's pretty common for programmers to issue updates to their software. Sometimes these updates cause big problems, right? You get a new update on one of your apps on your phone, and suddenly it keeps crashing when you try to run it. To help avoid these problems, development teams conduct regression testing. It's checking a new version against the older version to catch crucial errors in the version changes. This is a standard part of any process, and it helps prevent angry messages from users. Because if your favorite app suddenly crashes every time you try to run it since the update, there's a good chance you may be sending a message to the developer. It's like reading through your entire paper to make sure that the new paragraph you just added makes sense. And finally, quality testing. There's many good practices for testing the quality of a finished product. Separation of duties, ensuring each member of the team is aware of their individual and group responsibilities. ISO 9000, it's the international standards to maintain quality assurance. So check it against these international standards. Six Sigma, this is management techniques that reduce the likelihood of errors. And then there's something called sandboxing. It's running software without risking harm to the computer running the code. So you may put it onto a virtual computer and run it in case it might cause some problems on the actual hardware. Page 3, customer support. So you may think of customer support as the live chat on a website or a helpline you can call and talk to someone in India about questions you have about software. That's only part of it, though. Customer support is a big part of creating software and providing it to the public. It's how companies work towards customer satisfaction. So, how else do developers achieve customer satisfaction? Usability testing, right? Usability testing is a kind of a customer support routine that often takes place ahead of an official release of software. It's essential to gather data about how the customers use the software and what problems they might run into. So, this allows programmers to correct the error before it becomes bigger issues. So, data sets. How do you know what to test? Well, let's talk about data sets. Think of these as situations. Your program may run just fine when you use it, but another user might try something you didn't plan for, and then everything crashes. Suddenly, the software doesn't seem so great, right? You got a program that multiplies numbers together, and you're like, this is super. And then you give it to someone else, and they put in a negative number, and suddenly your program crashes. Like, what? So you never thought to try a negative number. This is a situation or data set you need to test. That's where users can be helpful. They come into your software and crash it for you, right? Because they think of things you didn't even think about. I didn't think anyone ever put a negative number in there. They'll create lists of information, data sets about situations when it didn't work as expected. They'll write it down. Oh, when I entered -3, it crashed. This whole process may seem time consuming, but when you take into account the value of a happy customer, it's totally worth it. Let's look at some different usability testing that happens to result in better customer service. Explorative. Explorative usability testing is used early in the process to validate the design approach, as well as the user understanding the product. Usually, a prototype is developed and tested with the full user experience in mind to find bugs quickly. Could be assessment. This testing usually occurs throughout the development process to evaluate real-time performance of the software. It determines the effectiveness and overall usability using tools like debuggers, which allow programs to step through code line by line to verify it's performing properly at different stages. And cooperative. Cooperative testing compares products, designs, or modalities, evaluating the strengths and weakness of each one. So testing a software program on multiple devices, let's check it on a phone, let's check it on a laptop, let's check it on a Chromebook, or testing different approaches allows a programmer to identify what's working and where it can be improved. Page 4, making everybody look good. That's another crucial part of maintaining happy customers is regression testing. As programmers watch their awesome software hit those virtual shelves, they know their job is not done. Whether you're developing on a mobile platform or creating a new operating system or building applications to meet some business needs, before too long, updates will be needed. With any luck, the inevitable bugs that show up in the first few days will be few and hopefully very minor, but you have to address them. After that, customers often come up with ideas for improvement. Hey, this app is great, but if it could do this, and they may ask for new functionality then. Programmers don't say goodbye to software as soon as you release it to the public. Usually it's a growing and changing experience, and customers want to know developers are going to maintain that experience with regular updates. Frequent updates make good software look even better if they work. So you may think you're providing a cool new update to your customers, but if there's an undetected bug in that new version, if it creates a security vulnerability or causes users to lose important data, suddenly everything looks pretty bad. Regression testing helps avoid this. It helps everyone look good. So let's look at 2 infamous bugs that should have been caught with testing but weren't and caused some big problems. Here's a go-to-fail bug. This was Apple had an SSL bug, also known as the go-to-fail. It created a vulnerability back in its 7.06 version of its software. There was a duplicated line of code. Right there, you can see go-to-fails listed twice. I guess this up. Does it get bigger? Yeah, you can see go-to-fail 48 and 49 the same. 49 wasn't supposed to be there. That was a mistake. All right. So that resulted in skipping a verification process and made it easier for hackers to, well, hack you. So it was probably copy and pasted, and they automatically pasted it twice, and then allow hackers to get into a lot of people's computers. Then there was April 2014. A security bug was found in the code associated with software that was used to encrypt private information by many companies like Google, Instagram, Netflix. It was later referred to as the Heartbleed. The bug created vulnerabilities and allowed for the theft of private information. It was patched, but not before damage had been done. And here is the code that was the culprit right there. That was the code that was the culprit. All right, let's look at page 5. Program testing, you be the judge. So what's the most important part of testing? Well, doing it. When testing programs, you want to be the one to find any problems if they exist, not your users. So test your programs using every possible scenario and then test them again just to make sure. Having a testing plan definitely helps make sure you don't miss anything. So are you ready to test some programs? Let's look at the directions here. Read over the code. You'll see a statement starting with the keyword return. A return statement sends the value back. So run the program, look at the output. So this says define convert temp. Now our define main is down here. This is convert temperature. So it takes a temperature and it subtracts 32, divides it by 5, multiplies by 9, and saves it as a new temperature and returns that back to the main function. So the main function has a temperature float, so you can enter, 71.8 if you want to, enter a temperature. Then the new temperature is, and it goes up to that convert temp function. It takes the old temperature, subtracts 32, divides by 5 times 9. And it says it's this. So this is a testing code. Let's run it and see what happens. Let's enter temperature. Let's enter like 32. It says the new temperature is negative 22 degrees. Let's try another one. Let's try like 212. It says that's 158. 72. See, I don't know what it's testing here. This is not a good program. If I'm entering Fahrenheit and it's giving me Celsius, then 32 should mean it's 0, right? 32 degrees Fahrenheit is the same as 0 degrees. But it said, no, it's negative 22. Maybe I'm entering Celsius. So let me enter 0 and see if it tells me it's 32 degrees. No, it's negative 54. Do you know what the program is doing? No. This does not give us a good picture of what's going on. This is not a good program. Let's look at the next slide. Oh, define convert to Celsius. And it takes, so this says that it takes a Fahrenheit temperature and converts it to Celsius. And here's the formula it uses. So Celsius is the Fahrenheit minus 32 divided by 5 times 9. F is a float value where you enter your Fahrenheit temperature. C is going to go up here and convert it. And then it prints those. So let's run the code. Enter a Fahrenheit temperature. Okay, 32 degrees, because we know that's 0 degrees Celsius. It says 32 degrees Fahrenheit is equal to negative 22 degrees Celsius. Well, this program is not even working. Let's try 212, because 212 should be 100 degrees Celsius. No. It tells us what it is, but there's something not working. Let's look at the next one. Read over the code. It says input 32 for the Fahrenheit. Look at the output. Here's the same code here, same thing here. Let's run it. It starts out setting the values equal to 0. Enter Fahrenheit temperature, 32. Nope, it's still wrong. Negative 22 degrees. So the output should read 32 degrees Fahrenheit is equal to 0, but it doesn't. There's got to be some double checking the math. So let's look at the next one. Fix the formula. Enter 32. Update the formula to produce the results of 0. Okay, so run program. 32 degrees. Still saying negative 22. I think it's in the order of operations. So let's see. What if it subtracts the 32 first? We put that in parentheses and then divides by 5 times 9. Let's see. If we put 32. Oh, it does say 0. How about when we put in 212? Does that say 100? No, that doesn't work. That says 324 degrees. Well, if we look at what the formula is, we do subtract the 32, But then you're supposed to multiply it by 5/9. We're dividing it by 5 and multiplying by 9. So that's a problem. We need to fix this. Multiply, and then we can put parentheses 5/9. 5 divided by 9. Now let's try running 212 degrees. Oh, it said that was 0. Wait a minute. That didn't work either. Fahrenheit minus 32 times 5 divided by 9. Why did that not work? 32 says 0. 212 also says 0. I wonder why. String F, 212 is equal to string C, and right here it runs the convert to Celsius. So it should take this minus 32, which would make it 180. 180 times 5/9 is not 0. I don't know why that's coming back with 0, because we do have that. I mean, even if I take out these parentheses, that shouldn't affect that. 212. Oh, now it did it. Somehow taking out the parentheses. That shouldn't matter. Now it's right, 100 degrees. Slide 5. Return the absolute value of x. Change the value of number to a positive number, 0 and 5. Okay, so it wants to test different numbers, a positive number, a 0 number, and a floating point number. Right now it's negative 12. It says the absolute value of negative 12 is negative 13. That's not correct. That's not right. What if we change this to a positive number? Let's make it positive 12. Okay, that's right. The absolute value of 12 is 12. What if we change it to 0? Okay, it says none. It should say 0. It says a floating point. How about 5.5? Okay, 5.5 works. How about negative 5.5? No, it thinks it's negative 6.5. There are some issues. Let's look at this. Now it's updated. Fix the code, it says. There's 2 logic errors. Okay, it's testing these numbers. Negative 12, 12, 0, 9.8, negative 9.8. And it's saying this should be the answers, which that should be the answers, because absolute value just takes away any negatives to make them positives. So if we run this, it says absolute value of negative 12 is negative 13. That's false. Absolute value of negative 9.8 is negative 10.8. That's false. And 0 is none. So we need to look and see, where is it doing this? If x is less than 0, return x plus negative 1. Now this should be times negative 1 to make it a positive. If it's greater than 0, return x. Let's change it to greater than or equal to. And now let's see if these work. Oh, now they're all true. Negative 12 is positive 12, 12 is 12, 0 is 0, 9.8 is 9.8, negative 9.8. That's what it took to fix it. We had to fix both of these, fix that statement and fix this if statement. All right, that was our last slide. So looking at our assignment, it's in Google Classroom. Let's go look at the template. This is week 34. And I do have the boost activity help if you need it, but let's see what our program says we have to do this week. It says testing a program that converts or calculates values. If you're given the program that converts or calculates 2 types of values, first it converts Celsius to Fahrenheit, and then it'll multiply a number times 88. So this says copy the code below and put your name on line 2, tested by. So you get to take this code, this whole program, copy it. Let's go to here. Let me delete that program. Paste the code. That's the first thing you do. Here's the program. And you put your name right here where it says tested by. Tested by Mr. Brock. Okay. Determine a set of at least 4 different values. You can test 10 values if you want to. You just have to have a minimum 4. Now look here in the red. Be sure to include integers, decimals, 0, negative, and positive numbers. Don't just test 1, 2, 3, and 4. Well, I tested 1, 2, 3, and 4. Well, you might have missed something. Look at the output and then correct any errors. If it's not displaying what it should display, find why. And then after your program is saved, save the program and turn it in. And here's the pseudocode. I've already filled in the pseudocode. This gives you Celsius number times 9/5 plus 32. The second one is just multiplying whatever number by 88. So like here is some expected output. Like you entered 10 degrees Celsius, temperature in Fahrenheit is 50 degrees. You entered 22. Your number multiplied by 88 is 1,936. That's what it should look like. You have 4 questions. The first question is, which numbers did you test? Were there any problems with the conversion from Celsius to Fahrenheit? And if there were, how'd you have to fix it? Were there any problems with multiplying a number times 88? If there was a problem there, how'd you fix that? And then why is it important to test your programs? So there's the program. When you run it, it's going to have you enter numbers. It says enter a temperature in Celsius. Okay, so when you run that, I'm not going to enter a number because I don't want you to see what it does. Does it have an error or does it not? It'll ask you 2 numbers. It'll say enter a number in Celsius to convert to Fahrenheit, and it'll say enter a number that I will multiply times 88. So you just have to fix it. You don't have to write any code. You just have to fix some code. Copy that program exactly like it is and put it in idle. Test your numbers, at least 4 numbers. Do decimal numbers, do 0, do negative numbers, do integers, do non-integers. That's what the decimals are. And if there's a problem with either section, fix it and then answer the questions. I found it wasn't doing this right, so I fixed it by adding this code or changing this code from that to this. Whatever you did, whatever you had to do. I will tell you, it's not error-free. It may not have an error pop up on there like, oh, this is an invalid something. Now, that may not be the error. It'll print something. Python does not know it has an error, but if you look at it, you go, wait a minute, that's not right. So there's a logic error. If it runs just fine, but what it prints out is not what it's supposed to print out, that's a logic error. Somewhere there's an issue. So there you go, guys. I've tried to make it real simple this week. I don't want to have any more programs assigned this late in the semester. We're not going to have any new programs. You just have to test this one. This is worth 50 points. It's worth a lot more than the 5-question quizzes, but it's not worth as much as if you wrote your own program. So there you go. Get this turned in this week. You still have time. It won't take you forever, hopefully. And we'll catch you next Tuesday. So have a great week. Weekends are about out.